Hi, I'm Coach Cowland, and in this presentation we're going to look at freefall. So what is freefall? Freefall is motion that is affected by the force of gravity. In fact, when we refer to freefall, we disregard any other forces, including air resistance. For the sake of our course, we're going to consider acceleration of an object in freefall as a constant. At the surface of the Earth, the value of acceleration due to gravity is around about 10 meters per second squared. To three significant figures, the value would be approximately 9.81 meters per second squared. Acceleration due to gravity could be written as ag or just the letter g. As gravity acts downwards, the acceleration due to gravity will be a negative value. In fact, it will be negative 9.81 meters per second squared. Because we deal with vectors, it's important to define a positive and a negative direction. For the sake of consistency, we'll define upwards as the positive direction on the y-axis and downwards as the negative direction. Air resistance is a force that opposes motion and slows it down or decreases its acceleration. However, as we mentioned before, we shall ignore the effects of air resistance at this point. When an object is released, what happens to its motion in terms of initial velocity and final velocity? How does this change if the ball is released from a higher altitude? Why do you think this happens? Make a note of your answers to these so that we can discuss them in class tomorrow. When you throw a ball upwards, what happens to its motion? When do you think gravity is affecting the motion of the ball? Make a note of your answers so that we can discuss this in class tomorrow. Let's have a go at a sample problem. A bird feeding its chicken nest drops a morsel of food from the nest to the ground. It takes the food 1.50 seconds to reach the ground, and acceleration due to gravity is negative 9.81 meters per second squared. What is the velocity of the food when it reaches the ground? First, let's identify the important data. As the food is dropped, it is released with an initial velocity of 0. The time taken is 1.50 seconds, and acceleration due to gravity is negative 9.81 meters per second squared. Listing my unknown variables and the variable I'm looking for, I get u is equal to 0, a is equal to negative 9.81 meters per second squared, t is equal to 1.50 seconds, and v is my unknown. When I draw my diagram, I include all of my variables and my unknown. The formula that best fits this scenario is v is equal to u plus at, and I don't need to rearrange it. However, u, the initial velocity, is going to be equal to 0, which means I can disregard it, and that means that v is simply equal to acceleration times time. Substituting in my values for acceleration multiplied by time, I get a final velocity of negative 14.715 meters per second squared. However, I need to remember the number of significant figures, which means that my final velocity is truncated to negative 14.7 meters per second.